Welcome to our third video in the Chemistry 1 Year 10 Science course. In this video we are looking at ionic bonding. Okay, so we've already mentioned in the first video that there's these three different types of chemical bond that can occur between atoms. We've got that metallic bond, which is bonds that are between metals, and we looked at that in our last video. We've got our ionic bonds, and these bonds are between the ions of metals and the ions of non-metals. So we did start mentioning about ions, but we're going to look into that further in this video. And our third type of bond is our covalent bond, and these are between non-metals where they share their electrons, and that we'll look into in our next video. Now, the properties of different compounds depend on which type of bonding occurs between the atoms. Okay, so we'll look at that today in terms of ionic bonding. In the previous video, we looked at that in terms of metallic bonding, and we'll look at it in terms of covalent bonding in the next video. All right, so first up, we obviously need to know what an ion is. Now, ions are formed when a neutral atom gains or loses electrons in order to have that full outer shell. So we talked about that last time with our metals. Now, when an atom loses electrons, it becomes positively charged. Okay, so there's more protons than there are electrons, so it's now got that positive charge. It's called an ion now because it's not balanced, and it is a cation. It's positively charged. If an atom gains electrons, it's now got more electrons than it has protons. It's negatively charged because electrons are negative. There's more of them, so it's got a negative charge. We call a negatively charged ion an anion. So we've got cations that are positively charged and anions that are negatively charged. Alrighty, so if we have a look here, we have got our sodium atom on the left, and you can see the protons and electrons are equal, both 11, so there's no charge. Okay, however, on the right here we can see we have a positive ion, okay, for our sodium. Now if we go back here, our positively charged ion is our cation. Okay, so it's a positively charged ion. It's lost an electron. It's got more protons. Remembering, protons are positive. It's got more protons. Therefore, it's a positive ion. And we say it's got a charge of 1 because there's one extra proton than there are electrons. So that is our sodium cation now. Okay, so just remembering that if a neutral atom has a loss of electrons, it becomes a cation because now it's got more protons and protons are positive. If it gains electrons, it becomes an anion because it's got more electrons than protons, and electrons have the negative charge. Okay, so now we're going to look at this concept of electronegativity and electrovalency. Okay, electronegativity can be defined as the electron attracting power of an atom. The higher the electronegativity, the more likely it is for an atom to gain electrons. Now, atoms with high electronegativities will gain electrons very easily, so that's what we're meaning. Atoms with a low electronegativity will lose electrons very easily. Okay, so high electronegativity gains electrons easily, and low electron negativities will lose them easily. Electrovalency is the charge of an ion that occurs when an atom gains or loses those electrons. Okay, so a couple of key words there. Now, if you think of our periodic table and what we've just said, okay, so we've said atoms with a high electronegativity will gain electrons easily. So as we move across our periodic table, these atoms will gain electrons easier compared to our metals over here, which will lose electrons easily. And that's all to do with how many electrons are in their outer shells, when you think about it. Okay, let's have a think about some common atoms and their ions. So we've got sodium. Okay, so sodium in its stable form has got 11 protons and 11 electrons, and its electrovalency is 0. Okay, there's no charge because it's got an even number of protons and electrons. The sodium cation, we're now Na+, because it has the 1 positive charge. Okay, and why has it got that? Let's think about this. The number of protons is 11, but the number of electrons is 10. It's lost an electron. Sodium is way over on our left-hand side of our periodic table, so it loses electrons very easily. Okay, so it's lost 1, and that's what's made it Na+. Alrighty, here we've got that. Okay, so you see how sodium has that 1 electron in the outer shell? It loses that one easily to make it a nice balanced outer shell like that. Okay, so the sodium ion has got 1 less electron, which means it's got that positive charge. All right, chlorine. Chlorine in the atomic form is 17 protons, 17 electrons, so it's balanced. However, chlorine, which is way over on the right-hand side of the periodic table, it's a non-metal, attracts electrons easily. Okay, so here we've got chlorine in the outer shell. We see we've got 1, 2, 3, 4, 5, 6, 7 electrons. It's gained 1 easily, okay, which makes it our chlorine anion there. So it's gained an electron. That's now a -1 because it's got 1 more electron, which is negative, than it has protons. So that's what makes it our anion. Okay, electronic configuration of ions. I've not got my fancy animation happening here, but never mind. Metallic atoms form cations, okay? So they lose electrons. They have a low electronegativity, so will lose their outer electron to leave them a full shell underneath. Where in the periodic table a metal is found will tell you which anion is likely to form. Okay, so remember in our periodic table, yep, and where it is tells you what it's likely to form. So for example, in group 1, they're going to form anions that are single ions. Okay, and then as we move across, we're going to look into that a bit more now. Okay, so as I was saying, sodium. Okay, so sodium loses 1 electron. Okay, so it becomes Na+, and there is that free extra electron, okay, with its charge. So Na+ means it's only lost 1 electron. If it had lost 2 electrons, it would be Na2, okay? Sorry, it wouldn't be sodium. It would have the superscript 2. Okay, electronic configuration of ions. So now we're going to think of some non-metallic atoms. Now these form anions. The higher the electronegativity of the non-metal means the atoms will gain electrons easily. Okay, so the further they are across here, the easier they'll gain electrons, but not our noble gases at the end. They're extremely stable. Okay, if we look at oxygen, oxygen gains 2 electrons and becomes O2-. So that's what I was saying about. With sodium, it was Na+. It could be a metal with a 2+ next to it. Oxygen is an anion, so that's 2 and the negative. Okay, so why do atoms form ions? Purely for stability. Okay, if you think of group 18, that's our noble gases. They're inert. They are completely stable. They're very, very unreactive, and that's because they've got a full outer shell of electrons making them stable. So if you think about it, helium, the shell is full. Neon, the outer shell is full. Argon, the outer shell is full. So they're extremely stable. All other atoms become more stable by gaining or losing electrons until they have a full outer shell, like our noble gases. Ionic bonds are formed between so we're thinking of these Ionic bonds. So ionic bonds are formed between metals and non-metals. The ionic bond is formed by a transfer of electrons from a metal to a non-metal. And then what happens is the non-metal has a negative charge, the metal has a positive charge, and those electrostatic attraction bonds them together. Okay, so here we're looking at sodium and chlorine. Okay, so the sodium atom has 1 electron in its outer shell, and the chlorine atom wants to become more complete. It's already got 7. It wants to gain another atom so that it can become 8. So the sodium loses an atom to the chlorine. The sodium now has a positive charge because it's got 1 more proton than electrons. The chlorine now has a negative charge because it's got 1 more electron than protons. And because of that, they're opposite and they have that electrostatic attraction between them. And that's what bonds them. This one's a bit more confusing. We've got magnesium. Now, magnesium's got 2 electrons in that outer shell. It needs to get rid of 2. Chlorine wants to gain 1 in its outer shell. So basically, 2 chlorines have got to come along and take the 2 outer electrons from the magnesium to make the magnesium then stable, and the chlorines are now stable with their full outer shell, and basically that makes the compound magnesium chloride, which has 2 chlorines and 1 magnesium. So our magnesium cation and our 2 chloride anions. Alrighty. Let's look at a compound that we all know very well, sodium chloride. So the first picture here, we can see sodium metal. The second picture here, we've got chlorine gas. If we react them both together, they produce sodium chloride crystals, which is table salt that we know. Okay, so the structure and properties of ionic substances. Ionic compounds are made up of many positive and negative ions. The ions are arranged in a 3-dimensional crystal lattice. The lattice is held together by strong electrostatic forces between oppositely charged particles. The ions in the lattice will be packed so that the ions of the same charge are kept as far apart as possible. That's that repulsion we spoke about. So this is what sodium chloride looks like. If you look very, very closely under microscope, it obviously isn't green and purple. It's just that to show you the colours. But the sodium ions are the purple, the chlorine are the green. Okay, so the Ionic model, you've got those ordered arrangements of cations and anions, with anions of opposite charge close together and ions of the same charge far apart. So opposite charges attract and the same repel, so ions of the same repel. So each sodium atom is surrounded by 6 chloride ions. The chloride ion is surrounded then by 6 sodium ions. With this model, each ion in the lattice is strongly attracted to its neighbour, resulting in a very stable structure. All right, a little bit more about ionic compounds. Ionic compounds. Ionic compounds are formed between cations and anions, and they're known as salts. The ionic compound formed between charged ions will always be neutral, as they cancel each other out. The total positive charge of the cations must be equal to the total negative charge of the anions. This is represented with the formula the empirical formula of a compound. The empirical formula can be defined as the smallest whole number ratio of cation to anion when all charges are balanced. It's a bit confusing, that one, hey? We'll come back to that. Okay, so our properties of our ionic compounds. They usually form crystalline solids. They have high melting points and boiling points. They do not conduct electricity in solid form. They have hard surface of the crystals are often difficult to scratch. Usually they're water soluble, dissolving ions into a solution. They conduct electricity when in liquid state, molten or in an aqueous solution. And they're brittle, so they shatter when a strong force is applied. And this table just shows you why all of those properties have that, why the structure gives those properties. And here are some diagrams that show that as well. So you've got the water solubility, you've got how the electricity is conducted, and you've got that brittleness. Okay, the last thing we need to learn is how we write ionic formula. Ionic formula are always expressed in terms of their simplest whole number ratio, or that empirical formula that we spoke about just now. We've got a couple of rules for writing the ionic formula. Okay, the cation, the positive ion, is always written before the negative anion, and the charge must always equal 0. What do we mean, guys? All right, we're going to have a look in a minute at aluminium nil, aluminium being bonded with oxygen. The first thing we need to do is write the cation first to make sure we include the electrovalency. So aluminium needs to lose 3 electrons. Okay, so it's Al3+. Next up, we need to write the anion, including the electrovalency, next to the cation. So the anion has now come up. We're bonding it with oxygen. We know that oxygen is the -2. So we've got our aluminium and our oxygen. We need to cross the electrovalencies over. Okay, so we're swapping and dropping. Okay, and now the 2 aluminium ions balance the 3 oxygens. So we get Al2O3. We show the subscripts only, we take away those charges, so we get rid of the charges. Alrighty? And that's just showing us what's happening now. Most ionic compounds have 2-word names. Okay, so like aluminium oxide that we just had. The first word is always the name of the cation, so the metal. The second word is always the name of the anion, so the non-metal. Best way to approach naming an ionic compound is to look at the formula to identify your cation and your anion, and then put the names together to name that compound. It's just a little bit more to that. Okay, our main block elements, groups 1 to 13 to 18. For cations, the elements in group 1 to 8 is just the name of the element. So for example, Na is in group 1, the cation is Na+, so it's just a sodium ion. Things are a little different when we look at the cations of elements that have more than one charge. Okay, so when dealing with transition metals, always check if there is more than one possible charge for the element. For example, iron. Iron can exist in a +2 or +3 cation. This is all getting a bit deep here, okay, so just have a read if you're hanging on. When naming anions with only one atom, when naming anions with only atoms in it, then we name it using the name of the element, except we change the ending. So the end of the element name is removed and we add an "ide." So oxygen becomes oxide, sulfur becomes sulfide, and so on. So this is if you've got a compound that only has one anion. So any compound ending in "ide" tells us there is one element in that part of the compound. So for example, sodium nitride tells us there is only sodium and nitrogen in that compound. Okay, polyatomic ions are groups of atoms that carry a charge. They can be positively or negatively charged and have specific endings that we use when naming them in ionic form. All right, "ide" tells us there's just the one, we looked at that. "Eighths" tell us there is more than one element in the ion and that one of those is oxygen. For example, calcium carbonates, we've got calcium, carbon and oxygen. Hydrogen sulfate, hydrogen, sulfur and oxygen. "Ite" is the same as for 8, but the number of oxygen is one less. So hydrogen sulfite, if you look, hydrogen sulfate there has 4 oxygens, hydrogen sulfite has 3. There's just your sulfite anions, 2 oxygens, and your sulfate anion has your 4 oxygen, 3 there, 4 there. That is all from this video. I will see you soon for covalent bonding.